Hi everybody, this is Ron Hatton, founder of Gadgetman Technologies and developer of the Gadgetman Groove. Since inception of the Gadgetman Groove in March of 2009, I've personally applied this modification to more than 1,600 engines, and you, by purchasing the personal license or any of our licensing programs, have just walked into a whole brand new world for fuel efficiency. Now, not every modification you do is going to be trouble-free. In fact, many times you can be expected to have to go back in and try to ID vacuum leaks or figure out why an engine has not responded. That's why we have the Groovy forums. We want you to register on the forums, become a regular poster and a user there, and post information about all of your modifications. Now, this training DVD is going to walk you through the entire process from start to finish on the modifications and teach you what you need to know to become an instant success. So on that note, I'm going to usher you on into the training with an introduction, and I'll say God bless y'all richly and warmly, and once again, welcome to Gadgetman Land. Oh, one more note. This training video is not the ultimate authority. This is a good guide. The best authority is going to be the training manual, which is updated a lot more quickly and a lot more easily than a video is. It's taken me 3 months to get this video to this stage. In any event, use the training manual as your first point of reference, and always check for the latest possible version by emailing Gadgetman at gadgetmangroove.com. And we'll talk to you soon. Bye-bye.
Hi everybody, and welcome to Gadgetman Land. Now you've decided to go ahead and take advantage of our training programs, and we are going to cover that in just a minute. So the first thing I want to do is introduce you to our package. Right now, what you're going to get is a DVD with 3 bits. That's it. On that DVD is everything that you need to be successful, including this video. Alright, now what I want to do today is I want to introduce you to our personal license packages. Now we do have 2. One is just the basic license. If you have some of these tools laying around your shop, then you're in good shape. But if you don't have, then you might want to consider the business in a box. Now, to start with, for the $500 package, what you get is you get 3 different sizes of 3 different sizes of bits. All right, one is very small. This one is designed for use on small engines like lawnmowers, weed eaters, chainsaws, that sort of thing, and works beautifully. The medium-sized bit, next size up, what it does is it does the carburetors, like this one you'll see sitting back over here. We'll get into that in a few minutes. But it does carburetors in the larger, like 2-cylinder engines. Then the large bit, which is the one that is used in most situations, they're used for the average passenger cars. So anyway, so that's what you get with the $500 kit. But trust me, there's enough in these bits if you just take a reasonable amount of care with them, keeping them cool, keeping them well lubricated, to do literally hundreds and hundreds of engines without dulling your bit. All right? Now, that's the basic license package. Now, if you find that you don't have the tools or don't have the time to go shopping for them, well, we've got a special deal, and we call it the business in a box. For $875 total, you get the bits, you get the training DVD, you get a Dremel 4000, which is what I use when I'm doing mobile modifications. You'll get an assortment of vacuum caps for use on all different engines. You'll get a couple of different shaping tools and a couple of drill bits to go with it that'll fit you. You'll get a polishing tool, sanding tool, that sort of thing. A package of JB Weld, which is used on about half of the modifications that I do, because they don't design it for the Gadgetman Groove, so the walls are a little thin sometimes. So what you do is you just patch it on the outside. We go into all that on the training manual. All right? A vacuum pump. Now you guys can find this at Harbor Freight for about 30 bucks, and on the shelf and online you can find them for about 40. The Dremel itself runs about $130. The flex shaft is another, I think they've gone up to $39 now. We also will include a printed version of the training manual and a printed version of the operations manual, so that you have a ready reference in your office and also in your shop. In addition to that, we toss in a clipboard, because you've got to keep your forms ready at all times. And this clipboard includes, also, we throw in 5 of the modification report forms for you so you can make copies. Again, a copy of that is also on the DVD for you. And a neat little e-pen from our U.S. Bank customers or partners. Also has a calculator and stuff on it. You also get a receipt book so that you can take care of the customer's needs when they get paid. and an activity logbook so that you can keep this in your shop and note down what all you work on. And if a vehicle comes back because you have to do some tune-ups on it or whatever, you can find the record and make additional notes as you need to. Ladies and gentlemen, that's our personal license package. It's very, very simple. The instructions are very easy to follow. And all we ask is that you share your information with us. I promise you great success in Gadgetman Land. Right, now, the first thing that I'd like to cover is to show you what you're going to be looking for under the hood. Now, if you look here, this is an Brock Performer Series, which is the most common replacement carburetor out on the market today. So you'll be seeing a lot of these, and they've got different base plates. So if you want to get rid of an old Quadrajet, which is the only carburetor I've ever found that I couldn't do. This Brock is the 1406, which means it's got an electric heater on it. And it's designed for Chevys. So this is what you're going to be looking at inside the car. Now, where the groove goes, as always, it goes in the area on the primaries alone on these carburetors. You don't want to do the secondaries because this area here is too thin, and if you cut two grooves, what happens is the grooves join in the center and it ruins your effect. So what you'll do is look for the primaries. They're generally smaller than the secondaries. The secondaries kick in only when you're in full throttle mode, which is not the best time to be looking for fuel efficiency. So the grooves will go on the area of the plate which is closest to the engine. So when the accelerator opens, the throttle plate passes over the groove. When you work on these carburetors, you're going to need to make sure that this throttle plate is all the way closed. There's linkage on the side of various configurations that you can see that throttle plate. Here, I'm going to move the linkage here. This is the fast idle cam. And you move it that way, you set the throttle screw down. You have to look at it until the plate is completely closed. At that point, you're ready to groove. You may choose to take a zip tie or something and tie this area back to where you know that the throttle plate is not going to move while you're doing the groove. That's the carburetors. Okay? They're all basically the same. That's the oldest style. Now, they may be 1 barrel, 2 barrel, 4 barrels. But then they moved up from that when they started coming in with computer controls, and they introduced what they call the throttle body injected systems. Now these are the injectors. This is off of a 305, 350 series of GM engines that came out starting in 1986 and then ran through 1995. And while they, right now today, these engines that are equipped with these don't get the best mileage. They're generally somewhere between 8 and 12 miles to a gallon when I see them, but when I leave them, they're anywhere from 20 to 30 easily. In any event, when you take these off, this is where the fuel lines hook up. So you'll need to have 1 wrench on this back piece and then 1 wrench on the line that holds it in. And you'll hold this one still and move the fuel line connection there and do the same thing on both so that you don't twist it up, because if you twist it up, you're going to wish you hadn't, and then you're going to have to make more trips to the parts store and all that stuff. A little trick when you're taking these throttle bodies off is you loosen the bolts. There's 3 bolts that hold it in place, 1, 2, and 3. 1, 2, 3. And they come in various configurations. There's a number stamped on the forward side of the car, of the throttle body injected unit, right here, that is the designator for that model. All right, so if you need to order one, you'll need that number. Now, so you loosen up these bolts. You do not remove them, just enough to where you can take these lines loose. And then you don't try to pull them out. If it's factory, it's a metal line. It's bent a certain way, and if you bend it, you're going to have a hard time aligning these things back up. So loosen the bolts, then take the fuel lines and drop that nut back out, and then lift the whole unit out of the engine. All right, and the vacuum ports will matter. This is your PCV port, so you're going to be capping this one off on every engine that you do like this. That's the throttle body injected units. From the throttle body units, advancements were made. Computer gained more and more control over the system, so they didn't need to have all the injectors up here. They moved to a multi-port system where the injectors are actually mounted just before the intake valve. Then the system, the throttle body, became a whole lot simpler. All you have is a cable that opens and closes the throttle plate, and you have a connector for the throttle position sensor. Now, some are a little more complex. They also have coolant lines run to them and a few other odds and ends, but don't worry about that too much. Just if you pull a hot engine in, make sure you relieve the pressure on the cooling system before you do disconnect any coolant lines you have. you relieve the pressure, and then once the pressure's bled off, you close it back down. As the engine cools, it will create a suction on those lines so that when you do take the coolant lines off, what happens is it pulls the coolant in rather than pushing it out. You don't want that stuff spraying you in the face or wasting anything if you can help it. Now, once again, on the back side, let me just pull this tape over here, it doesn't matter. This is what you'll be looking at. This is what is the idle air pathway. It goes through a channel on the intake manifold. A lot of them have them here where they vent right into the throttle body, or they manage through a valve on the outside of the engine. But the groove, again, just goes in the area that turns toward the engine. It goes in the throttle body there where the plate is closest to the engine, I should say, so that the plate will move over the groove. It's the same in every engine, Some imports in the 90s have computer-controlled throttle bodies, but that was the next advance that hit the U.S. market. Now this is a throttle body off of a 2003 Hummer. All right, as you can see, there's no cable. So what there is an electrical connection here that hooks up, and inside this is a little electric motor. So that when the computer sends a positive, or if it sends a negative voltage, then the throttle plate will snap shut, which is what happens when you turn the key on in these GMs. Then it'll relax a little bit to the idle position. Then when you turn the key off, it relaxes completely. Right? In some GMs, this will cause what's called the Gadgetman plop, which is caused because of the groove that's machined in this plate here. You may be able to see it from that angle. Since the groove is always charged with air, when the key is turned off, it cuts off all power simultaneously to the system. So the groove is charged with air, the engine's running, then the computer turns it off and it tries to relax it. Well, what happens is the pressure inside the groove will snap that throttle plate shut, and it makes it sound as though you're slapping your hand on the end of a hose. Let's see if I can make it happen here. Something like that, only a lot louder. Okay, so those are basically the throttle bodies you're going to be dealing with. Some will be a little more complex, some will be a little less complex. So next step is we're going to cover how to do the groove. Alright, now the first thing that you're going to want to do with every vehicle you touch is to get a copy of your modification report form. As you can see here, I've already had the customer fill out all of our information here so that we can have it in one place. Now we have her name, address, telephone number, email address, and it's very legible, so if you have problems reading their email address, please take the time to write it out underneath there and ask them to confirm it. Then we have the year, make, and model of the vehicle, size of the engine, and we have the mileage count on it, 183,000. Now what you do is you're going to look at this form, and it's going to give you a little bit of information to start with, especially when you look under the hood. So, as I see here, it's got 183,000 miles on it. Well, a little known fact about oxygen sensors is somewhere about 50,000 miles they give up the ghost. And what the computer does is when the oxygen sensor begins to get a little sluggish, it quits using the oxygen sensor as a point of reference to remap the fuel trims. And if it's not going to change the fuel trims, you're pissing in the wind as far as getting good results. You've got to make sure that all the equipment is up to snuff and they follow the proper maintenance cycle. So the first question I would say is, when did you change your oxygen sensors last? In this case, I know that they were only done about 3 months ago. So we know that we're good on that. And the current mileage is there so that you have something to compare it to. Now, we actually started out at 9 miles to the gallon on this, and we are now happily over 24 on the highway. If you happen to have an emissions analysis on the vehicle, there's a spot here for before and after. Immediately after, you'll see some tremendous changes, and then after the runs, there is a slot for that. Your form may be a little bit different. This may change, but it's basically all the same information. So the service date goes here, so that's where I should have filled that in, was the date, today's date, and then I'm the service person, and you want a record of that because you may have other people working on it, and over here will be a source, so I'm going to see this change. This is going to be changed. And so if you got them as you're wandering around town, if somebody called you from the website or sent you an email, or a friend told a friend told a friend told a friend, you want to put where the source of this modification came from. Underneath it, there's an item and then a description. Because the first thing you're going to put here is mod, which is the modification, and then the PCV adaptation, if it has a PCV. 98% of the vehicles out there do have. So then you put that down there in the price. As we have also other products, like we've got a resistor that goes into the intake air temperature circuit. We have a resistor pair that goes into the postcat O2 sensor. If you add those, then you want to put them down here. Also, if you run across anything particular with that vehicle, any issues with either getting the throttle body out or location of the PCB, that if you had a difficult time with it, please make a note of that and make that a part of your report. Okay? Then here's a spot for the customer to sign it. There's a spot over here for them to initial it, to authorize the use of their information for your marketing as well as ours, and then the mention of the guarantee. All right. So we see the form is already filled out. Now she did this while I was working on the vehicle. Now the first step with every modification you want to do is to check to make sure that there's no service issues with disconnecting the battery. Some vehicles, they're rare, thank God. But some vehicles do require a special procedure when you're changing out the battery, so you might want to call your parts store or check in your owner's manual of the book to find out if there's any problems with that. Because what happens in those select vehicles is it turns on their anti-theft. Now, you just need to be prepared for it, because those all have automatic locks on them, and all you need is that little key fob to unlock the car with, and when you do that, you lock it and you unlock it using the key fob after the battery's reinstalled, and that should reset your alarm, okay, and allow you to start the vehicle. Now, the first thing you want to do when you pop the hood now is you're going to take a look. Now, if you come on over here, we're going to identify everything. Now, you see, this is our air filter over here. And then there's the air tube, and here's where they put the mass airflow sensor or the intake air temperature sensor, or both. And actually they have both. Usually they combine them now. But this right here is your intake air temperature sensor. This is the spot for one modification. We have a 3.3 ohm resistor that we put into that. And then the air flows through the filter box all the way in through here, and then into underneath that cover is where the throttle body is located. All right. Now you're just looking now, and you can see that this engine's got some pretty good hoses, so there's probably not going to be any real issues with vacuum on it. What we do is we pull that cover off, and then we pull the throttle body out. We're going to skip over a lot of that because that's pretty self-explanatory. There's a bolt there, there's two bolts over here, or one bolt over here, two over there, whatever, and the cover just pops off, and then you just remove the throttle body. Our concern right now is the battery, because one of the first things you have to do is get that computer reset to where it can accept the new fuel trims. Now, this is the procedure for clearing the ECU. It is very, very, very simple. Most engines nowadays will use either an 8 or a 10 millimeter bolt on their cables. As you can see, this one here was kind of jury rigged. I certainly did not do this work, but I have managed to hold it together for about a year. We have to replace all our cables, and that's why that hasn't been done yet. But what we're going to turn our attention to is the negative cable here. And all it takes is, and this one is an 8 millimeter wrench. You just loosen it up, just a little bit like that. Then you take and you pull it off. Okay, so now the cable's been disconnected. Now you got to get it where it's not going to be reconnecting, because you will fry your jumper wire. But I've made a jumper wire here, and it's got a couple of different connectors, because it doesn't really matter what type of connector you use, so long as you connect the negative cable, like this right here, the one end of the clip, over to the positive. Then, that's it. And then what you do is you turn the key into the run position. So you roll it around where you would normally be starting the engine, and then just release it to where it falls back into the run position. And you just leave it like that while you perform the rest of the modification, which should take you about a half an hour, sometimes longer. You'll get faster as you go. All right, so that's clearing the ECU. See how easy that is?
All right, now most of the throttle bodies that you'll be cutting will be very simple. The newer throttle bodies, though, do require a little bit of setup before you do them. And those are the electronically controlled throttle bodies. So that's what we're about to show you now.
Alright, now guys, we were talking about the drive-by-wire, fly-by-wire, computer-controlled throttle bodies, and what I have here is a throttle body off of an 08 GMC Yukon, which is just all the General Motors the same. But if you look down here, this is how you tell where to put the groove at. If you'll see that black line right there, you can see it. That is the exhaust gases. That marks the natural idle position. Let's see if we can get real close there. So what we're going to do is we're going to slide that throttle plate closed, and we're going to wedge it somewhere like that, just where a little bit of the black line is showing, and that's where we're going to cut the groove. Now I'm going to set this down. Maybe you can see what I'm doing, but what I've done is I've snagged a business card from my bank right here, and my business cards work good too, but I'm running out of those. So anyway, what we do is we take this and we simply place the business card in the upper section of this, and then we push it closed, and then we inspect it to see how close we are. So let's look. Look. You see how little of that black line is showing? Some is, but not very much. We're looking at maybe a maximum of an 1/8. So I'll probably push that a little closer shut, but that is how you find the position on fly-by-wire throttle bodies to cut your groove. And again, the groove goes on this side right here. Because of the configuration with this throttle body, it's got a high scoop to it here, then I'm going to go with a steeper angle on my bit so that we can be sure to get the full groove into the throttle body itself. There you go, guys. Have a great day. Alright, now I just finished grooving that throttle body, and I want to show you where I started, where I finished, and what it looks like. See, there is the throttle body. Of course, we start at the far left over here, and we do a little scoop, a little scallop every time. Now, this one's done by the master, of course, but as you can see, there's still some scalloping, and that's okay. I don't worry about that at all. But you can see how where the bit actually brushed up against the top part of the throttle plate. That's the starting point. You look down, and you can see that there is. Let's see if this thing will focus a little better. Okay, you can see there's a little bit of clearance here between the throttle plate and the groove. I don't know if you can see that clearly from here or not, but there you go. You can see it there. All right. Now looking at it from the front side, you see there is your black line. Now I'm just going to pop this loose. Real simple. All right. Push her down, push her around, and pull out your business card, which is now wasted. So now, when you look down at the throttle body, and this is the test, you look here, you can see the groove, you can very clearly see the black mark, which is the natural idle position. And we close this up, that's where the engine will be idling, right there. It's going to relax that far. That's how much room you have before the groove actually gets in and kicks into full force, right about there. So there you go, that's the Vortec, and that is how to do a computer-controlled throttle, and these GMs, they're funky. So anyway, enjoy your adventures in Gadgetman Land. Alright, now what we're going to do now is we're going to talk about using the bit. So we got the throttle body off of the vehicle. Now we're ready to move into cutting the groove. Alright, now what we have here, this is the normal throttle plate assembly. It's usually not that thick. It's a little out of scale, but I'm not an artist. I am a gadget man. Alright, so the throttle plate's here. All of the air is moving this direction in the throttle, okay, and here's the engine, goes into the engine this way. Well, since all the air is hitting this plate, all this air is moving this direction, what happens is all of this air here gets compressed because it has to go down the plate. In order for it to continue moving, it has to come down the plate. Alright, that makes all of this air be forced in this small area, so it becomes extremely dense. Here, it's very low pressure here. This is where your air bleeds are, okay? Now, so what we're going to do is we're going to apply the groove just past the throttle plate, so that we can get the waveform that we need. Now, when the air is moving properly, what happens is the air will come in this side of the groove and curl up this way. The part above this will just go in and become the intake airstream. For the first half of the downstroke, this ball of air is built, but then you've got other air coming in this way that comes down this way and then is gathered up this way. In order to get these two balls of air to be the proper dimensions, you have to have the groove cut at the correct angle. Well, actually, this should be down a little bit more. Anyway, let me just wipe this off, and we will take a look at how to do that. Okay. All right. Okay. So now here's your throttle plate. You're going to use this as the backstop for your cutting. You'll see that in just a couple of minutes on the DVD when Greg starts to cut the throttle body. Now this is one of the bits. Okay. You can see it's kind of like a half round shape. It's not exactly, but it's close, all right? And in order to get this cut correctly, now you have to use the bit in the proper manner. So if you take the bit in your Dremel and you do this with it, which most people want to use it like a pencil, right? No, because it's going to make your groove incorrect. The bit is shaped perfectly to create the groove. So what you have to do is when you put it in, you have to take the bit up against here, it'll be like this, okay? And then you move it down in that fashion directly. So you have to take it like this and move it this way. So you kind of lock the angle with the Dremel. You use the backdrop of the bit, you hold it straight, and you go down. Now, there's two or three angles that you've got to keep straight. Number one, flat against the throttle plate, okay? And then as it goes down, it just slides in and cuts the groove because you're moving the bit straight down in. The straighter you move the bit, the more accurate the groove will be. So do not do this and do not do this. You want to keep this flat both this direction, this way, and this way, so that you get the proper shape. And it takes a little bit of practice, don't worry about it. That's why you got these bits, is so that you can practice with it. Then when the groove is shaped correctly, what happens is the bit will go in here, and then when you put it in afterwards, it'll lock into position. And the more wobble you have, the less accurate your groove is. What you're looking for is about maybe at the most a 20-25 degree angle for maximum efficiency. So when you put it in the groove, you'll wiggle it back and forth like this. And again, we'll show you that in a few minutes. But if you look at your bits, there is a 15 degree angle right here just past the bit cutting, the cutting surface. The cut's cut all the way to here. Right? This is undercut so that this angle here, when it's perfect, will lay flat on the throttle body like that. This is the angle of your Dremel, and here it's attached this way in your chuck. Okay? So as you see why you have to move it straight. And just look at your angle. If the plate is a little bit too steep, then change the angle of your bit, because you have to. This is the most important spot to look at when you're cutting the groove, is the angle at the taper just past the cutting surface. You'll see it. Alright, so that's the angle you want to be parallel to the airstream. Alright, now we're going to go on and we're going to cut the groove.
Alright, now what I've done is I've pulled a few throttle bodies out of inventory here to show you some of the variables that you'll run across. Alright, this one right here is the computer-controlled GM throttle bodies. Now, you can see in its natural rest, you can see down in there, you can see where the groove is. This has already been grooved, so you don't have to worry about that, but I'm going to show you how to position this. If you look at it very closely down in there, you can see, especially in this area down here, I'm going to point at it right there, you see that black mark running in, okay? That black mark is caused by the idle air gases as they swirl inside the intake, and it shows you the natural idle position of the throttle plate. So you'll know exactly where it's supposed to be. Now there's people that are testing doing a reading on their throttle position sensor. You can do that if you want to. It takes a lot of extra time. So I'm going to show you the way I do it here in Gadgetman Land. Now these are my patented spacers. All right, I'm sure you've seen those before. You would use anybody's business card. You know, I don't mind. But I use my old ones. So what you do now, you're going to want to see the throttle position somewhere where that black line just barely does show. You can see, I don't know if you can see it, but I can from here. So you want to just barely cover that spot. Actually, it looks like it goes. I'm looking at the black mark back in this corner here. It looks like that's about the natural idle position. So what I'm going to do is I'm going to slide my business card up in there like this, and then I'm just going to push the plate closed until I see that we're covering the natural idle spot. And that looks like that's about right. So when you go back onto the back side, you'll see where it needs to go. Now, in this particular model, we did cut through right here. All right, this is what you're going to be looking for. If you see right there, you would have been able to see light through that hole. So what we did was we took a little drill bit, which comes with your business in a box. This is a 1/8 inch drill bit, so that it fits into the collet of your Fordham very nicely. And you just take this into your Dremel and you clean it first, then you take and you rough up the metal really good with the drill bit and just scrape it good to give the JB weld something to bond to. Then you mix it 50-50,
and put a little sprinkle of aluminum shavings. You can see I've got plenty laying right here on the counter for just exactly for that purpose. I don't throw anything away if I can help it, if I can find a use for it. All right, so we roughed it up, then we just filled it with JB, and then what we do is we take some of this here where the JB weld was applied and sprinkle it down in there and push it in. All right, and then just leave it like that for a couple minutes, then just dump it out, and you're done. Okay, and that's how you get the groove. Now the groove is positioned in this way here, so that when your bit goes into it, you start. This is slightly curved. It rolls up with the throttle plate. So that's going to cause your angle to be a little bit extreme, but you see that bit right there fits nice and snugly into that hole. That's the wobble. You can see that in the diagrams. That's very, very, very tight. Okay. And actually, this should have been grooved just a little bit closer to the throttle plate, I think, to take maximum effect of the groove. If you get 1/16 of an inch too far away from the, well, just put it this way, 1/16 of an inch difference in position closer to the engine will cut your results by probably 25%. So you want this to be as close to the natural idle position as possible when you cut the groove on these controlled throttle bodies. With the other ones, you don't have to worry about measuring it like this. But once you get that position, then you just put your bit up in there, and you buff it up against the plate, and you just make your groove. That's it. Now, these I don't like doing them. They're indicative of too much controls in the computer system, and I prefer doing the older cars because the people that own the older cars really need the help more. Now here is a Ford throttle body that is unmodified. It's just a junkyard part, but that's what I'm doing is I'm buying junkyard throttle bodies and offering them back up on our eBay store, which we haven't got an eBay store yet, so we're using them in our mail-in modifications. All right, now if you look at this, it's got a little swirl here. Now in some of these engines with this throttle body, they have an idle air screw that's right here. There are one of these, either here or here, I can't remember exactly which, but it was on the earlier versions. Then they just didn't cut the holes. All right, so what it does is it lets air from this side of the throttle body back through this passageway controlled by a screw, and then into the intake manifold through that passage right there. All right, you don't have to worry about that on this model. We're going to be grooving this one for you in just a minute to show you exactly how to hold your bit, how to tell when you've got the bit in the right position, in the right angle. Everything is going to be revealed to you in just a couple of minutes. All right, now this is another style of throttle body. I don't remember what this came off of. I think it came off of an older 3200 GM engine. But what I wanted to show you was the idle air pathway. If you look real closely, you can see this one's been filled in all here with JB weld. Normally that would be open. But the idle air pathways, they're handled in so many different ways, it's not possible for me to show you them all on a single video, so I'm not going to worry about it. But you can see that this has been filled in here with JB weld, and the way that's done is you open the throttle plate up, and you put a business card, once again, I'll just reach over here and pull this down. I can. Waste not, want not. And you'll take and tear the business card a little bit like that. It's better when you're doing JB welding on these to use. Real estate agents have the nicest cards. They're always nice and shiny and pretty. Well, the shiny business cards have a plastic coating that prevents the JB Quick. Again, that's what you're going to be using, JB Quick. You can see it comes in two parts. But you got to get a backdrop for it. So you stick this in there and you just position it where it's right even with the top of the throttle body, kind of like that. It's very simple. And then you've got a curve right here that matches the shape of the throttle body. Then you fill this in with JB weld. Remember, this is your idle air control valve. It's drawing air through that little tiny opening. I don't know if you can see it in there right there. That's your idle air control entrance. It goes in through that hole, comes back through this valve, through that bored hole. That's a cap in there too, by the way. And then comes through the valve and then out this hole right here. Well, I'm running V8 engines off of holes that are 1/8 of an inch in diameter. And this hole here is slightly larger than that because it needed to be to manage the engine. But what you do is you fill it in here, then you take the rest of your business card, you lay it here like this, and you turn it upside down on the table, and you just block it in where it's going to sit flat, and then you just let it sit there for 15-20 minutes till the JB weld hardens. Then, or the JB Quick, excuse me. Then this card will be stuck there like that. You just peel this off, just rip it off real quick. If you do it too soon, then the JB Weld will tend to come out with the card. You don't want that. So make sure it sets at least 15 minutes before you attempt this, or you're going to have to go back and redo it. So you peel that card off. Now you've got to start. Now you can take and you can sand that down. What I use is a flapper sander. You've seen these before. One comes with your business in a box, and you just take and buff it up like this until you get the same level of everything. One thing that you'll find extremely important to have in your Gadgetman operations is a good sharp pocket knife. Because what you can do to speed this up until that JB Quick hardens all the way is you can take and slice it back and forth like this. You can see the scrape marks from where I've done this throttle body that way too. And you just take and cut it off like that, and then you examine it. And if you're smooth, you're good to go. You can tolerate a couple thousandths of an inch without a big deal because you got a gasket that goes here. Oh, speaking of gaskets, if you're going to pull a Honda throttle body, always have a spare gasket handy. You always have a spare gasket handy because they're not carried in every town. I had to do one the other day, and when you take those Honda throttle bodies off, they have cement on both sides of the gasket, which locks the throttle body to the intake manifold. And I've never done one what that gasket has not come apart. And in many pieces most of the time. So what you have to do is either be prepared to make yourself a new gasket, and I'll show you how close I keep my gasket material. You see, I don't even have to move. It's right here. So you can make a new gasket if you need to. The gasket material is extremely inexpensive. I've had this for about 2 years and still haven't used but about half of it. So Hondas, have you a gasket handy? The reason I say with Hondas have a gasket handy, don't make you a new one, is because of the way the idle air is routed. And if you make your own gasket, 9 times out of 10, there'll be no air to run the engine in an idle. Okay, so now you have that. Once you've built that up, then you open up the plate and you just tear that card out. And then you've got a nice shape here, and you've got a nice shape here. It's all flat, and you're good to go. But you still need to open up that pathway. Now what I do is I take a 1/8 inch drill bit and I drill right back into the hole. Okay, it's a good idea if you remove the idle air control valve in cases like this because you don't want to drill into the piston and cause it to malfunction. So you just run a drill bit in there. All of the JB Weld is falling to the bottom, right? When you set it down on the table, and then you just drill a hole out there to let some idle air in, but not a whole lot. Okay. Alright, so now we go to bit selection. Now this is where a lot of people have a great deal of difficulty, but it's really one of the simplest things in the world to do. What you got to do is you got to look at the space from the throttle plate. You can see that's the plate, that's where the groove is going, right there. The side that turns toward the engine is where the groove goes, and it goes as close to 180 degrees as you can get, which usually means about 160 is maximum. Alright, and this is one that we'll be able to put the maximum groove in. So you simply take your bits. I have one of each size here handy. Okay. So small, medium, and large. And you can know that the small is definitely going to work. But that's not big enough. You want to use the largest bit possible for every application, the largest bit possible. The medium, well, that will work without a doubt, but it's still not quite enough. Let's try the large one because I know the large one will. And if you look, you can see that all of the cutting surface is contained within the throttle body itself. If the bit rides out where the edge of the groove is going to be outside the throttle body, then you've got too large of a bit. So go down to the next size smaller. That is all there is to it. Okay? Don't worry about cutting through on the outside. We've already shown you how to handle that, like with this one right here. Use a flashlight, go inside, out, and outside in wherever you suspect there might be a leak. Hold it in the dark. Use only your flashlight and then cut it. Alright? So, now, this is a Ford throttle body, pretty standard equipment on most 4.6 and 5.4 liter engines. Now, we've got our bit selection. We know that we're going to use the large one because it fits. Alright? That's what I usually keep in my drilling lab. What I'm using is a professional version. It's called a Fordham. I'll show you a picture of it. The handle's a little bit different. It's more bulky. But I've had this thing for years and have never had any problem with it, whereas I do a lot of modifications. So you guys won't have such an issue, but I've gone through dozens of Dremels wearing them out until I bought this. All right, now, this is my device is on a pedal feed. I'm going to lift it up to the camera so I can show you. This is the pedal feed. So I can control it all with my foot. Now you can hook up something like this to your Dremel also, and they work beautifully. It comes with a plug this is the outlet plug, so that you can plug your rotary tool right into that. These are, you can find them on old sewing machines or whatever, but they work great. All right, so I can drop it down there where I can get to it. All right, now one of the keys to making your bits last longer is keeping them cool and well lubricated. If you short yourself on this, your bit is not going to last nearly as long, and as a result, you're going to be wanting replacement bits, and while you're on the personal license program, there are no replacements available. So take the time to make your bit work as long as possible. Take care. The way I do it is I take this right here. This is just a coffee cup, of course, but inside this coffee cup, I use power steering fluid. You can use transmission fluid, oil, cutting fluid. I understand there's some far superior stuff out there, but what I want to do is show you the way I learned this, and you can enhance it as you go according to your needs. Now, first thing I do is I dunk the bit into the fluid. Now, I don't like getting sprayed, so I give the Fordham a little kick to throw the excess off. And then I come over here. Now, you'll see in the manual that the bit cuts right to left. So that's the same motion that your hand is going to take, but you don't want to overtax your bit. So what you want to do is make your cuts small and make them frequent. Plus, if the bit gets hot enough to melt aluminum, then aluminum begins to stick inside the cutting flutes, and well, have a nice day getting that out. It's very difficult, so you'll need a set of picks. Craftsman makes a great set that's available at Ace Hardware now too. That's where I found mine. Anyway, so now you're getting to the point where you're ready to cut the groove. We're going to start over here. Now, this axle is made out of case hardened steel in almost every throttle body I've ever seen, so it lasts a good long while. But if you hit that axle with your bit while it's running, you are going to dull your bit very quickly, and it'll be worthless to you. So just stay away from that axle shaft. So I start about where I've got one bit width between the top of the bit and the axle shaft. Now, I'm going to be looking for the right angle. Here's the trick. All right, guys, pay attention. All right. So I'm going to fire up my rotary tool, and I'm going to brush up against the plate. Then I'm going to show you the scuff mark that's made and how you can use that to indicate whether your angle is correct or not, or to get the best angle you possibly can. So I'm just going to start. I'm holding the throttle body up off the table so I have some flexibility with it. All right? I don't brace it here because that makes it rigid, and you need to be flexible to correct your angle as you go. All right? So here we go. Brush up against the plate. Now, what I'm doing, I have to calm down for you. What I'm doing now is I'm leaning my hand, and hence the axle shaft, or the shaft of the Dremel, towards this center mark right there. Okay? That's how you're going to get the right angle every time. So when I run up against it there, what I did was I stayed away from the throttle body itself and just buffed the plate to see how good my angle was. I'll come in real close there, and hopefully you can see that scuff mark. I roll it around. But if you'll take a straight line from where my cut is going to start to that, what we're looking for is we're looking to get an arc that's just like this, that bisects the edge of the bit. If you're leaning the bit too far to the right, then you're going to get cut over on the right hand side. I'll just go ahead and show you. As a matter of fact, I'll show you on the dark area so that you can see it more clearly. Okay? So first, I'm going to lean the bit to the left. I'm just going to go straight up. Okay, I'll lean the bit to the left. And what you get is you get a cut on the left-hand side. Lean it to the right, and you get a cut that goes on the right-hand side. Lean it directly up, and you can see the arc goes directly across. That's how you know you got your angle straight. So without further ado, I'm going to go ahead and start the cut. You'll watch, I'll reposition myself until I get the angle correct. There we go. That's it. Now just drop it down, make sure I get the right angle. Notice I'm taking my time. There. If you just heard that, you heard it release and it picked up speed. That was when the bit was in maximum depth. That's what you're listening for when you let off the pedal. Get the bit out of the groove as quick as you can. Now, I'll show you what a good angle is. If you look here, you can see that the angle of the bit is up by about 15 to 20 degrees. It's somewhere in that range. Now, when you do your cut, if you get out of there quickly, then what you'll get is you get a case where you can see there's like no side-to-side motion of that bit. It's locked into place. That's what you're looking for. The closer you get to zero movement, the closer to a perfect groove you have. So, let's go ahead and finish this up. Now, always go back, buff the plate before you cut again. Make sure you got it cut in the right position. Very lightweight. Don't put a lot of pressure on it. Let the bit do the work. Your job is to keep the angle correct. Well, the first cut, the bit isn't hot yet. So now it just released again. And I drag it slightly to the left, keeping the same angle. There. Now I dip it in and I hold it for a few seconds, just so I know it's cooled off, and then I hit it again, and I come back and I do it one more time. There. I hope you guys can see that scuff mark on that blade. Very easy, very light touch. I've seen people start out with this, putting so much pressure their hands shook. But these bits are really good. There it goes, it released. And I'll cut it off. And I only cut out the scallop part of the bottom. As long as you hold the angle right, then you'll get consistent results. Now, if you're going to bang the shavings out of your throttle body, be aware sometimes these throttle position sensors stick out below, and if they do, you might wind up cracking it off. Okay, so be careful what you're doing. Alright, now on this particular throttle body, now like I say, each one of these is different. In this particular throttle body, I don't know if you can see it very clearly on the camera, but what happens is it comes up to about here, then there is a bevel, a chamfer if you will, that angles down slightly. So what will happen is as I get closer and closer to this area with my bit, the bit will go deeper and deeper to accommodate the extra depth caused by the chamfering. We don't worry about that because our goal is to get the groove in there in appropriate shape, in appropriate position, appropriate angle, appropriate. But it's not a perfection thing. Do not seek perfection on this. The groove is not going to be perfect the first time. You'll get better with it as you practice. Again, cut and dunk, cut and dunk. Now you want to get your bit into your coolant solution as quickly as possible. Because what happens if you use a hydrocarbon-based solution is you'll actually can make your bits harder. At least that's the theory, because what they do when they're case hardening steel or when they're tempering steel is they heat the metal up to a certain point, then they allow it to cool in a hydrocarbon or in something heavy in carbon. The ancient Japanese used just high carbon ash, which was just wood ash, and they stuck it in there in a warm environment and let it cool off extremely gradually so that the carbon molecules bonded with the metal. Little trivia there for you. Again, every time you'll want to fire it up and sure your angle is right. There we go. And just drop it down at that angle into the metal. Very gently, so your bit doesn't overheat. Because once it gets to about 740 degrees, that aluminum's going to start sticking. You do not want that to happen. It doesn't take long to cut the groove, so don't hurry. In and out, and by now this throttle body is starting to get kind of warm, so I'm going to make sure that I keep my bit very cool down and give it time. We don't want to mess it up. And that, my friends, is cutting the Gadgetman groove. Now, I want you to look very closely in here, and you'll see that that wall is almost perfectly flat. You can still see marks in there where the bit rolled, where I didn't have my angle perfect. But again, this is not a perfect science. All you're looking to do is get that shape into the passage as the air flows this direction. So what you see left to right is only an indication of how accurate your groove is. And I have to say that that is probably one of the prettiest grooves that I've ever cut. Let me give it a rinse real quick. Okay. And there you go. That's the Gadgetman groove. You like it? Well, you're going to be making your own real soon, Mike. So, anyway, if you'll notice there's a little bit of a ridge there, a little space, a gap between the throttle plate and the groove itself. That is perfectly fine. Don't worry about that. But that looks as good a groove as I ever done. So, anyway, let's cut the groove. Now, what I'm going to do is I'm going to show you on a whiteboard why it's important to do what you just saw on that video. All right? Because the groove was perfect if you take the top of the groove, just roll it out flat in your mind's eye. And what you're going to have is you're going to have something that looks about like this. Okay? And then it'll be round off on the edge. Something like that. Okay? That's what you should have when you're done, if it's a perfect groove. Alright. Now, if you turn the bit too far to the right, remember the buff marks on the throttle plate will tell you whether you're too far to the right or to the left. So you keep your angle correct. If you go off, well, let's go on down here and do it again. This is supposed to be a perfect groove. Of course, remember, I'm not an artist, I'm just a gadget man. There's your perfect groove. Well, what happens when you take and you lean it too far, we'll say for this illustration, that you lean it too far to the right. Well, what you're going to have here is you're going to have a groove that goes into the throttle plate here, right? Because that's about your bit shape. And then the bit will actually cut this out even wider, okay? So what you'll wind up with is a groove that looks like this. You get the general picture, but it makes it too wide here as well. This will all be breathed out, but that all gets wider here, and it also gets deeper this way. So, that is not the correct shape for the groove. Too far to the right does that, makes it too wide, and it makes it too deep. So what you wind up with is the wrong aerodynamics, and your groove, if you do it like that, will wind up, this is the way it's supposed to be shaped, okay? About like that. Now when you do this, what winds up happening is this winds up being more choppy on the back end, but what really hurts you is on this end because it changes the shape of the groove. And you wind up with losing this area here, gets cut out, and this winds up being a lot wider and flatter. That means that this area right here, where the air is supposed to be captured for the largest ball of air rolling up this way, you lose that, so it can't capture as much air. In addition, this area down here winds up being in the wrong position, so it can't thrust that up at the right angle. So you wind up with it pushing directly into the wall when it comes time for it to expand into the system. That's why it's critically important that you get your left to right as well as your vertical. Because if your vertical is too much, if you're too steep, then what happens is the groove comes like this, and the air comes down here, but too much of it catches this way. And this groove this ball of air on this side winds up being too small. If you're too shallow, then what happens is the air that's coming in winds up going this way and starts out in the wrong direction. It's got to come down this wall and roll up this direction to give you the proper effects. So that's why this angle is selected. The angle is 15 to 22 degrees. Now, that's a pretty precise measurement, but if the bits are supposed to have a taper on, we found that there's some in the batches that aren't exactly, but as long as you have the angle of 15 degrees, get yourself a protractor. You can pull up an image of one online. And guys, that's your #1 resource. Online. Use Google. Do a search. Find out where's the PCV valve on the vehicle that you're using. Do the internet searches. But when you pull up an image, you'll be able to look and see that's 45. Half of 45 is 22 and a half. So here's 90 degrees. Right? There's 90 degrees. There's 45. There's 22 and a half, somewhere, well, that's actually about 20, right? So that's the angle that you want your bit to be at, right about there. You have a small range, it's about 5 degrees range right there. There's another 5, and there's another 5. So all the way up to 45, right? So that's about the right angle. Right in that range is where you want your bit to be held, and then the left to right this way. Right? That's why we do it the way we do it in Gadgetman Land. Hi, and welcome again to Gadgetman Land. Now, as you learn to master this technology, the first thing I want you to remember is to do at least 6 modifications before you make any kind of decision as to whether it's worked or not. Because quite frequently, vehicles do need additional service work. The most common reason for failure is, of course, a vacuum leak, because the Gadgetman groove amplifies the pressure curve. So you look at it like a hose in a hole in a garden hose. You put 5 psi, now that's the normal state of what your engine's in, just a very low vacuum. 19 inches is not much. You put 5 psi on a pinhole in a garden hose and you'll get a drip. You put 50 psi and what you'll get is a stream of water shooting 30 feet into the air out of the same size hole. Well, this similar change in pressures occurs within the Gadgetman Groove modified engine. So vacuum leaks are very, very bad. So get yourself a vacuum tester, a pump down unit. Smoke tests do not show vacuum leaks, although they may show major ones. They won't show the smaller ones, and the smaller ones become big ones. The second area where we're finding a very consistent failure with the engines to respond is, believe it or not, in the oxygen sensors. Come to find out that after about 50,000 miles, which is the normal service interval on the oxygen sensors, they should be changed every 50,000 miles or so, that they begin to get sluggish and the computer will fail to recognize them as a valid reference point from which to remap the fuel trims. So the fuel mileage stays the same. Power will come up, the emissions will drop, you'll see all the other benefits, but the amount of the fuel delivery will not change because the O2 sensors are sluggish. So if you've got over 50,000 miles on a vehicle, before you even do the groove, say, look, when was the last time you changed your oxygen sensors? And if they say never, then you can probably bet that the vehicle is going to need new oxygen sensors, at least the upstream side. Okay, those are the main air-fuel ratio sensors, in some cars they're called. But that's what they're there for, is to make sure that the fuel ratio stays properly adjusted. Now, as you go out into the community to introduce this, here's what I do. All right, I carry a stack of business cards with me at all times, so that I'm always ready to talk to somebody, especially if I see a gas guzzler on the streets, and we know what those are. The older the vehicle, the more likely it is that it is heavy on fuel consumption. So look for the older vehicles first. They're the most reliable with the Gadgetman Groove. Older vehicles and non-computer managed engines. All right, I have tripled the gas mileage on many older Fords with the Motorcraft carburetors in there. Of course, they did require rejetting and some tuning of the carburetor, but triple the gas mileage is certainly doable on those. The last one was a 74 Ford F250 with a 302 in it, and I took it from 8 miles to the gallon to over 24 miles to the gallon. So, and that was a quad cab, full-size bed, fully loaded, camper shell, everything on it. That's why its mileage was only 8. But after the groove was applied, she couldn't even tell she was carrying a load. And that's a very common response too. So older Fords. My top #1 vehicle that I like to find is the throttle body injected General Motors pickup trucks. Now, we're not talking about the Suburban series. There's something about the Suburbans that I believe is in the climate control, but I can't be sure, that thwarts a good portion of the gains. But the TBI pickup trucks, on the other hand, they're marvelous. I double the gas mileage on those on a regular basis. So they do have issues with vacuum leaks. The 305 and 350 series frequently have intake manifold gasket leaks. There's a diagnostic for that too, but you can just get a hold of me, I'll tell you about that. So all this stuff you can find out. But okay, so the older Motorcraft carbs, my #1 is the throttle body injected General Motors trucks. And then you go to the 1998 to 2002 Ford Truck series, and they respond marvelously too, also with about double their gas mileage. Our O2 Expedition that I used to have went from the best ever mileage of 9.8, and that was downhill from northern Arizona into Phoenix, and at 10 miles under the speed limit. It was 9.8 miles to the gallon. After the groove, it jumped to 24. Okay. Then it tapered back to 16 in the city, but it was still a very respectable 16 miles to the gallon in the city, where the best we could ever get before was 8. Okay, so those are the vehicles that I would look for, especially if I'm just introducing it into a new community. But do every engine you can get a hold of. But when you're introducing it to people, the best approach that I've found is that, well, I'm a discoverer. Well, so are you. You discovered the groove, maybe not the same way I did, but you did discover it. In all likelihood, you probably watched a minimum of 15 videos before you even sent me a note. You may have hung out on the forums. I've had people that have hung out on the forums for over a year before making the decision to get their personal licenses. Maybe you're one of those. But that's what they're there for. They're there so that people get the straight scoop. So your next step, get on the forums. Step after that, go to YouTube. Go to the Gadgetman Global page, the channel there, where we've got most of our videos, and watch as many of those videos. Every day you should watch 2 or 3 of those videos until you've learned them like the back of your hand, because that's what you're going to be sending your customers to. Now what I do is I take a business card, always have business cards. I take a business card, and if I find a vehicle that matches my profile for preferred vehicles, then I'll take and write on the back of it what I've seen happen on those cars and invite them to call me, and then I'll stick it under their windshield wiper or in the door of the car so that they have something to take a look at. The #1 source for leads to GadgetmanGroove.com is YouTube. Over 60% of our site traffic clicks on the links at the bottom of our videos, so feel free to use that to benefit others. Okay? Once you've done a vehicle for a stranger, they become your friend. Remember that. You're looking to make friends here and to help people. So friends help other friends. When the modification report form that we have up on the website and also on this DVD has a referrals section on it. There's a 2-pager, so have it printed front and back side so that you can save paper. And then when you're done with the modification, turn it over and encourage them to give you the names of their friends and family, and tell them that if they'll refer them, that you will give them a $50 discount in their name. You know, what could be better than saving money and also saving the planet? So I hope this has given you some pointers as to how to introduce the groove. Be gentle, be kind, as though they're fellow adventurers, and you're just helping them find their way. If you ever have any questions, of course, I can be reached at 406-361-0491, and I want to hear from you. So if you're under the hood of a car and you run across an issue, use that phone number, program it into your phone, save it, because there will come a time when you'll wish you had it. So keep it available to yourself. Now, if it's a non-emergency, if you're not under the hood or you're not in front of a customer, then put it on the forums and let's all learn about it. So that being said, it is a great honor to have been chosen the one to deliver this technology to you guys, and it is a great honor to have you as part of the family. So on that note, before the tears come too much, I'm going to say God bless you richly and warmly, and as always, remember to smile for a stranger today. You will both be glad you did. Bye-bye. Now get to work.